All right, so yeah, my name is Mike Hartington. I'm a developer advocate on the Ionic team. I am also Angular GDE. I also post a lot of pictures of my cats. So if you want to see cats, I hear the internet runs on cats. Definitely go to my Twitter. If you notice the name, it's not the same thing. There's a story behind that, but you have to find me afterwards to know the story. So I want to start this off with a bit of an experiment and kind of share like a user experience almost. So let's just try this out. If this fails, I'm so sorry and I wasted your time, but I don't think it's going to fail. Fingers crossed. OK, give me a second. All right, a little bit. I promise it's going to work. All right, well, actually, this is part of the slides. So if you're trying to load a website most of the time on like either a lower end mobile device or say in a subway or in the Atlanta airport as you're trying to go from one gate to baggage claim, you might see this little spinner or like this little notification up on your phone as you're trying to load a website. This is a really poor user experience. And what we've actually have numbers on this is about 14 seconds of actual loading time that most users face when they are trying to use a web app these days. This is actually from a study from the Chrome team. Adi Osmani wrote an amazing post called The Cost of JavaScript in 2018. Please give it a read. It's the first result on Google. It's definitely eye-opening to see where most web apps, where they face their slowdown. Now, there's kind of a few different areas. We have network speeds. We don't really have control over the network. There's device limitations. How much RAM does a phone have or the laptop? How good of a CPU does it have? Those are things beyond our control. But one of the biggest slowdowns one of the biggest reasons for slowdowns that we as developers have control over is JavaScript. There's megabytes of JavaScript being sent down, sometimes not minified, sometimes not optimized, and this is the #1 cause for a slow web app and a poor user experience. And business use case here, it's like no one's going to wait 5 seconds for your app to load. If it doesn't load, I'm just going to go with something else or just not use your site. So how does this relate to progressive web apps? So progressive web apps are the claim that they are going to solve all of these problems by providing that optimized experience. If you've used the Twitter PWA, this is a really good use case. If you've used the, I think there is an Instagram PWA as well. Another good use case, but they're supposed to provide a fast experience that can work in network constraints, device constraints, and give users a better experience. But I think this is kind of a misleading term or idea. Essentially a responsive website that works fast and is offline. And I don't know who said that, but they're really smart. But even then, that's kind of like, responsive web, what's that? It's like so 2008. Responsive web design, who cares about that? Really, PWAs are just marketing words. There is no idea of a PWA that you can sell. You can't, hey, I'm going to sell you a PWA. It's like, no, you're selling a website. And most of the key points of a progressive web app aren't really anything to do with progressive web technologies. Can you make your site fast? It's kind of a no-brainer. You should be able to make your site fast. Can you make your site progressive? If I load it on, say, Safari, which has limited features, to say the least, it shouldn't break. What about security? Yeah, your app should be loaded through HTTPS. And that's kind of a solved problem, I would think, because most browsers will display an actual warning if you are not loading your site in a secure manner. And then maybe the only part that is kind of a gray area is integrated, but your users should be able to visit this site or this web app and have an improved experience. They should be able to see, hey, it's not just website. I have like added to my home screen, or I have some kind of icons, or it's changing my URL bar's color. It should have some nice features. So if we know what progressive web apps are, and we know that JavaScript is the main point, can we build a progressive web app with Angular? So let's actually, I'm going to change the display settings real quick. I'm so sorry to the video people if that messes things up. Sorry. So this is actually a web app that I have built for the conference. It is a quick little conference app. So let's see, securing web applications. This was an awesome workshop by my friends at Auth0. Community happy hour, looking forward to that. We can go to speakers tab. Hey, there I am. I promise I didn't do anything magical to make my name appear first. It's just how it appears in the database. And we have images loading up. We have Jeff Cross. We have the map. We have some information about the sponsors. So we have a little bit of a better experience than a typical website. It feels like a nice app-like experience. But how does this look when we go ahead and say, bump up that and say, what if we go to slow 3G? What if we go to 4 times CPU slowdown? These are just settings in the Chrome DevTools. What if we reload the page? How does that web app look? Well, thankfully, we have statistics and ways to measure this. We have a finished load time of about 6. Nope, that's not the numbers that I want to look at. But we have a pretty nice loading experience. We can reload. We have all this data coming in. The app feels fast and snappy, even though we have slow network connections and probably a limited device. What if we just go offline? Cool, the app still works. It defies all network connections. We can still see some information. We can still navigate around and have this app just work. Cool. So how did I build this? This is, I would say, a little bit more fun than a Hello World app. But your mileage may vary. But I would say if you are building an app, you should probably try to hit these 3 key points. Make your app fast, make it cache, make it last. I'm kind of proud of myself on this because it took forever to figure out a word that is close to fast and cache. That's the only little bit of patting on my back that will do. So let's dive into the first subject of making the app fast. So if we know that JavaScript is the main reason that our apps are slow, what is the inverse of that? How can we make them fast? We just ship less code. The fastest app out there ships no JavaScript. But it has nothing to do, it has no interactions, it has no animations, all that fun stuff. So what can we do to still have JavaScript but ship a faster app? And because we're in Angular, we're going to look at lazy loading best practices, and then kind of a more framework agnostic approach is looking at the libraries that you use. So lazy loading, you probably should be lazy loading as much as possible. Not only is this cool to show off to your friends that you know how the lazy loading system works in Angular, but it also reduces that initial size for your chunks. So in this case, if we lazy load our entire application, our main JS is actually going to shrink down a significant amount. Now, one app I've built in the past followed this kind of pattern, it's called the app shell pattern, where we have a single component loaded at the index, and then the rest of the routes, which are not really my main routes that I need to go to, we can just lazy load them on demand. For the conference app, I did a little bit of a different approach. I lazy loaded everything, but I also had this tutorial page that you could see if it was your first time going to the app. But if you had already seen that app and you didn't need to go see the tutorial, don't bother loading the tutorial, even though it's the main route that you should go to. So we can use the CanLoad property in the route definition, and we can create an injectable that would go through, say, get this value from storage. If it's true, navigate to this route, and then return false. That way we're not loading the tutorial. Vice versa, if we haven't seen the tutorial, load the tutorial route itself. So this is fairly simple, maybe 20 lines of code, less if you don't count the imports. But this is a pretty nice way to just handle all of these different conditions. Other ideas that you can do is to start grouping your routes together. So for instance, if you go to a user profile page and you know there's a user's image, user's post, group them together so that way they might be in a, they might increase one chunk size, but you can have that experience all loaded in at the same time. And then take a look at the preloading strategies for the Angular router, because you can start to request these routes in the background when the network is down or when the network isn't busy, and have this app just kind of load right in. So for libraries, raise your hand if you've used Moment.js. Basically everyone. Moment.js is huge. And by default, you get all Moment.js, all the locales, even if you don't need them. A better option is to use something like datefns. And in this case, I imported the format function, and I only had about 9 kilobytes. Because it's using ES modules. Definitely stuff that you should be doing. Datefns is one example of a date and time library. There's other options out there. But 9 kilobytes versus 335, I'm happy with that. Raise your hand if you've ever used Lodash. So hope you see where I'm going with this. Lodash is probably 70 kilobytes. And while that doesn't sound as drastic as 300 kilobytes, or over 300 kilobytes, that's like the size of several portions of an app. That could be, and that's just one library. You might be using one method or two methods. You are paying a huge cost for that. Who's heard of Lodash ES? Not as many people. So Lodash ES is literally the same code that is Lodash. It's just exported out as a different way. You can import each function as you need it, and then tools like Webpack and Rollup can tree shake everything else out, and instead you only get 5 kilobytes. Much better, right? And I'm not changing anything about the app. I'm just picking the libraries, which is very important. Now, the only plug I will say for Ionic is this is how we do things internally. We will go through and just load the pieces of components that you need as they are being rendered inside the app. So that way you're not paying the cost for like all 100 components that we have, but just the ones that you need. Now, if you wanted to dive into the tool, your app, and figure out where's the size coming from, there's tools like the Source Map Explorer, which can analyze your source maps and say, hey, this is why your app is this big. Angular CLI also has a pretty awesome feature called budgets, where you can start to set restraints on, okay, my vendor bundle should only be this size, and if it's over it, throw a warning, throw an error, break the build. Don't let it go out over like a megabyte, right? So make it cache. How can we make sure that our app is resilient to the network? We're going to use a technology called service workers. There's an awesome talk later on about service workers, so I'm not going to spoil that talk, but basically we can have a way of caching all these assets. And this is probably a snippet of code that many people have seen when they look at service workers. Just do some feature detection. If we have service workers available, register it, and then handle that promise. And then we have something like this, which is any Service Worker 101 blog post will show you. There's nothing really real about this service worker. It's just trying to get you introduced to the ideas. Definitely check out this site there at the bottom, servicework.rs. Here's a real service worker. That's not something anyone really wrote. That's all just generated. So service workers are actually a very complex thing. If you think about caching, a lot can go wrong. And it's probably best to use a library. There's better libraries out there than writing your own. this workbox, but we're in Angular, so we're going to use the Angular service worker library. Again, I'm not going to steal too much from the talk later on, so be around to check it out. It's JSON-driven approach. We have all the different ways to configure service worker and figure out, hey, if the cache is 5 days old or however old, clear it out and go to the network. Pretty simple example. This is what I have for the conference app. Nothing too drastic. And then I can go in, and once that service worker has been written, it can be registered in my app's root app module. And important thing to note, I cannot stress this enough, only enable it for production. Because if you start caching your dev server and you start making changes to the template and things don't update, you can get pretty annoyed. Ask me how I know. There's also some nice utilities in here to check for updates from the server. So if your cache is out of date and the server has something new, update it and reload the browser. And maybe you want to do push notifications. But there's a pretty nice tool to get this into your app without having to go through some manual work. And that's a schematic for ngAdd. If you run ngAdd AngularPWA, you're actually going to get a service worker, get it automatically added into your root app module, and get all the configuration for it basically done for you. And you just have to tweak a few different pieces that are specific to your app. So what about making it last? We have things caching. How do we make it last? How do we create this lasting experience where people are like, hey, it's on my device. I don't really have to, go out to the browser anymore. And that's going to be with the app manifest. So the app manifest is a pretty straightforward file. It has some interesting parts, which I'll get on them in a little bit. But it's a nice way to say, hey, I have an app. Here are some icons that are associated with that app. Here's a long version of the app's name. Here's a short version. And here's some kind of theme colors that the browser should be able to read. For the conference app that I built, we have the one right here where we're saying, OK, the name is going to be ngAtlanta. If we are saved to the device and we are limited on space, we'll just use ngATL. I have a start URL, so if the user has already saved it to the home screen, they should be redirected to the schedule right away. They don't have to go through that process of loading up the tutorial, seeing if it's there. Display mode will be standalone, so you won't have any browser UI. Orientation is pretty self-explanatory. Portrait primary is actually pretty interesting. Basically, I don't want to lock you into a portrait only, but I kind of want to default to portrait. And you have the same thing for landscape as well. Icons are a complicated point. There's no defined rules for what size icons you should use and how many icons you should have. There's plenty of linting tools that'll say you need 72 by 72, 94, 112, 192, 124, 512. I don't know what the limit is, and there's really no good docs from any of the browser vendors that say you need these icons. Every single one seems to be a bit different based on device resolution. And this isn't just really a problem with the web. Native has this problem too, so no one's figured out this whole thing called scalable vector graphics. So we also have these last two, which were a bit troubling to me, background color and theme color. Now, I would expect these to be essentially the same thing, but apparently there's some difference in them, and we'll get into that in a little bit. But they are different. We basically want to set a color that is our app's overall theme. Now, when we want to add this to our app, we just add link rel manifest, give it a path to our generated manifest file, and we get a little something like this. So we're going to open up the browser real quick. OK, and I'm going to pause it real quick. So the browser hasn't even finished loading the URL, and it's already started to read that manifest. So it's already said, hey, there's a manifest on this index. Let's change the URL. Let's change the omnibar or URL bar of the browser to fit that theme color. So that's where theme color comes in. but I already have like a better experience before the app has finished loading. It feels like it's right inside of the browser. It feels like it's part of the OS, which is really nice. But as we keep going on, the app loads. We'll go to the home screen. We'll tap on ngATL. We have our own launch image basically made for us by the browser. So that background color is actually used here to generate its own launch image, take the app icon, and superimpose it onto that background image. So we have this already given to us for free without having to do anything. I think this is really awesome. But we continue on. Our app loads, and we have the display mode set to standalone, so I don't have any browser URL bars. My app feels like it's a truly native app. It just happens to be built with web technologies. What an idea. And I'll let it load just to finish it out. Now, the manifest itself, you can write this manually, but it's already part of AngularPWA. So as you add AngularPWA, you're going to get a manifest. You're going to get it automatically injected into your index.html. And it's already going to include a few different icons. In this case, they're going to be the Angular logo. But you could pass those icons off to a designer on your team, have them use those sizes as like a placeholder or a template, and generate your own icons for your app. So this is everything that I kind of did with my app to make it a PWA, essentially. How can we measure this? How can we say we are hitting these metrics or we're hitting these key points? Well, there's two tools that we can use. The web page performance tests, and in Chrome specifically, we have Lighthouse. I'm pretty happy to say web page performance test gets A's all across the board. It's a fast app. It's using an effective cache mechanism, and everything's basically compressed and optimized. Performance for Lighthouse. Lighthouse is a very fickle tool. Some weeks it'll be really, really great and make you feel like you did a lot of great work. And some weeks it will just hit you really hard right here. And it's not a problem with you, it's the tool. It kind of changes pretty frequently. But one thing to note is that these are 3G conditions. This isn't going to be a maybe realistic use case. But if you are loading your app in a 3G network and your meaningful paint time is 3.7 seconds, I would consider that a success. And of course, we hit 100% on PWAs because we have all the service worker caching our content. We have an app manifest in there, and we're doing everything we can to make sure our app is resilient against network changes and as fast as possible. So that is the demo, but I do have some bonus material with the limited time that I have left. So everything I showed you is all part of the core Angular experience. I do want to give shout out to two community tools that can help you as you are building out your app. So there's a project called ngToolkit, which is schematics and tools all around Angular Universal. So if you wanted to host your app on Firebase and you want to have some server-side rendering already done for you, ngToolkit has a schematic that will automatically bootstrap that for you and handle the boilerplate. There's also a tool called ngxBuildModern by community member Manfred, where it will do, go Manfred, where it'll do differential builds for your app. So if you are on modern Chrome or a modern browser with ES 2015 and ES modules, it will only send that code to that browser. But if you're on old versions of Chrome without ES6 and modules, it'll give you an ES5 bundled application. This is something that we see in different toolkits like the Vue CLI, and I would love to see this get into Angular CLI and be a core feature. So with the last bit of time, just keep in mind, 14 seconds might not seem like a lot of time, but it is a painful amount of time when you're trying to load maybe a bus schedule or some important information, maybe going to a hospital, maybe you need to get your insurance out. You can have a lot of, you can justify all of that with 14 seconds. So the demo for this is up on GitHub, Hartington ngATL conference, and the app itself is ion.ngATL, hosted on Firebase. Thank you, Firebase, and thank you.
I like that.
Yeah.
Like that. It was clean. It didn't talk too much about service workers. I think people conflate the two all the time.
We didn't want to give too much of the hints away for the next talk.
That was like, Mike's a stand-up guy. It was really good of you. But what I really want to know is, what's a bad use case for a progressive web app? Because everybody talks about like, oh, use them all the time, but that's not true. Is it? There's probably like cases where you don't want to use one.
Or that you don't need to. Maybe that's another way too, is like, they look awesome, they're great, do we always need them?
I mean, I tend to think that there's always a use case for progressive web apps. I don't think it's the idea that progressive web apps are going to be something everyone should use, but I think the ideas of a progressive web app are applicable across the board, no matter what type of app you are building. Your app should be fast.
Yeah.
That's not really like a key thing of a progressive web app. That's like what all apps should do. Your app should be working offline. It's like, it should have all these features, not really just because it's a progressive web app, just because.
No, it's fair, and I think it's becoming more and more important when we think about building a web for everyone too. Is like, I'm even glad to see in your demo you had 3G connection. We're not looking at the conference Wi-Fi is never good, so whatever. But we're not looking at the really fast internet speeds that we may have in certain parts of the U.S. We got to think about our applications working in lower connectivity countries and markets. That's important. You want people to be able to access your site or application immediately as fast as possible.
Yeah, I mean, tools like the browser's DevTools, it may be simulated 3G, but it's better than not testing on 3G at all. Web page performance tests, they have all the options, so you can load it in a 3G environment, maybe fast 3G or slow 3G. So you have all these different options where you can say, oh, I'm on a really good network connection, or I'm on not great connection. So you have all these different options, and yeah, you got to test for it, or else users are going to suffer.
Yeah, I mean, we can't get away with it works on my machine anymore.
Right. I mean, the example of loading it in the subway at the airport.
Yeah.
First off, Atlanta having a subway in their airport is cool, but network doesn't work down there.
No.
I'm trying to find my schedule, or at least order an Uber. I couldn't do it. I had to wait.
You got to wait until you're up out of that subway.
Right.
And
but there's cases, maybe not ordering an Uber is a good example, but just trying to load something in these varying network conditions, you should be able to account for that.
Yeah, no, completely agree. It was an awesome talk, by the way. Just
Thank you.
Always fun to talk about PWAs. So
Always.
It's an unfortunate name that it's just, oh, PWA, so how can I build that? It's like, no, it's just a technology. Build around the ideas.
I mean, it was a sexy way to talk to it. It needed its own acronym.
yeah.
Come on.
That was good. Well, thanks, Mike. Next up is someone from Google.
Yeah.
So it's great because now I know everybody that the company work at. So people that work at Microsoft going to complain about Bing. People who work at Google going to complain about Lighthouse. Me and Mike are going to do that. So it's great. Any other companies I want to complain about?
Well, I mean, people can complain about Netflix if they want. We're here.
Yeah,
there's like other
what's
people.
the deal with Choose Your Own Adventure as a TV show?
Yeah, I mean, look, in the morning we were talking about how good it was. So.
Yeah, but you know what? I'm a completionist. I need to figure out all the endings, and I have no idea how many endings there are.
We'll just keep watching.
I can tell you all the endings later. We'll talk later. Thanks.
All right, thank you. That was awesome.